Hello and welcome to Lesson 4, Comparing Data in Two Variables. We are going to talk about a topic called linear regression, which is how we pretty much start to interpret multivariable studies and data analysis. And this is really where we start getting into a lot of stuff. Now this lesson, if you read it in the chapter, it's very symbol heavy and arithmetic heavy, very complicated arithmetic, but Excel helps us get away from the BS, so to speak. It really simplifies the mathematics that we have to do, and we can focus on the interpretation as opposed to getting hung up on multiplying and dividing numbers needlessly. So the first thing that linear regression talks about is a scatter plot. A scatter plot is a graph of points, x and y, each of which represents one observation from the data set. One data variable will be represented by x, which we call the x variable, or this is the predictor variable. We talked about that way back in chapter 1. The data variable will be represented by y, or the y variable, is the response variable. Each piece of data is plotted on a graph depending on the x and y. When you do a scatter plot, you have to draw an x and y axis. You need to label each axis clearly and then plot the data. So let's look at an example, and I need to get my pen tool here. Pen. And I need to change the color. All right, so the first thing I need to do now, we have all positive numbers, so I need to draw an x and y axis. So my y-axis is the up and down axis. All right, this line is not going to be straight. I'm not that talented at drawing straight lines, even when there's one for me. And just like magic, axes appear on your screen that are semi-straight. So remember, my y-axis is up and down, my x-axis is left to right. So now I need to plot each data point. I need to come up with a scale. So my x in square footage goes from 90 to about 554. So this is 0 right here. And when our data doesn't start at 90, at 0, we can put in a broken bar on the axis to represent that there's more to the numbers, but we're just not there. So I'm going to start my scale at 90, and I'm going to go by tens. Yeah, tens should work. No, tens will not work. So I might have to go by 20s. Let me just pause the video and make sure I have an appropriate scale. And just like magic, a scale appears. I decided to go by hundreds, so I changed my 90 to 100, but I left some space so that I can draw my 90 in there. So 90 to, and then we also have to label our axes. This is the square footage. And I'm going to pause so I can write this. All right, so while I had the video pause, I started my scale on my y-axis as well. I'm not going to plot all these data points because you'll get the point, and I'm going to show you how to do this in Excel. But if we were to do it by hand, we would go 90 is about here to 200 and plot a point. Then we would go 132, which is about here, to 423, which is kind of right here, and plot that point. Then I would go 139 to 300. Oh, that's 150. And plot that point. Now, they're not going to be perfectly linear, but I would have a bunch of dots here. Let me show you that. Now, I didn't do all the data points because I didn't have enough room on my y-axis, but all right, so I've copied and pasted the lot footage and sale values to Excel, and I'm going to show you how to do that. So the first thing I'm going to do is I'm going to select my data. I'm going to go to Insert, Scatter, and I'm going to select the first one, and then it's giving me something weird because I selected my data incorrectly. So I'm going to delete that, and I'm just going to select this data. go to Insert, Scatter, first one, much better. All right, now there's stuff that's missing here. We need our labels. We don't need this legend, okay, but we need labels. So I'm going to go to Layout, and I'm going to click Chart Title because I need a title above chart. This is lot, square footage, and sale values. Now I need axis titles. Primary horizontal axis title, title below. This is square footage. Let me see if that works. It does. All right. Now I'm going to, I'm going to click on my chart again. I'm going to axis titles. I'm going to go to primary vertical axis title. I'm going to go with rotated title. You don't have to. And I'm going to say sale price in thousands of dollars. Enter. All right. So there's how you would plot the scatter plot. Now, if I were to take an estimation, I would say that this data is positively correlated, but there's some more stuff that we need to do in order to make that happen. So let's go back to our PowerPoint presentation. When we talk about linear relationships, we have a positive relationship, a negative relationship, or no relationship. Positive, if you were living on the trend line, it would be like you were walking up. Negative would be like you were walking down. So when data is correlated, we say that there is a relationship within the data. We can calculate a statistic called the correlation coefficient, or R, to help us judge if there is a relationship with our data. Few facts about R. R will always be between -1 and 1. If R is less than 0 and our data, then our data is correlated negatively, which means that the data appears to be on a downward slope. If R is greater than 0, then the data is correlated positively. If R equals 0, we can honestly say that there's no relation. And the closer to 1 or -1 the R value is, the stronger the data is related. We really need a number close to 1 or -1 to make any assumptions. Here is a chart, basically, or a list of how strong our numbers can be and how we can state if they're correlated or not. If anything is greater than 0.7 or between 0.7 and 1, the variables are positively correlated. If it's between 0.33 and 0.7, we can say they're mildly correlated, etc., etc., etc. I will post this PowerPoint up so you can read that and always have that for access. Now, just a note, correlation does not imply causation. Just because there is a relationship in the data value does not mean that one caused the other. It just means that they're related. Now, this is how you calculate the R, where this is your every data value minus the mean times the other data values minus the mean of those data values over n-1 of the sample size times the standard deviation of the x values and the standard deviation of the y values. This is obnoxious. I do not want you to try this by hand. It's nuts. Alright, so I'm going to show you in Excel how to do the R value, and then I'm going to go back to the slideshow and talk about line of best fit, and then I'm going to switch back to Excel and show you how to do it. So I'm going to move this guy over here. So when I'm looking for my R value, I'm going to type in equal, C-O-R-R-E-L, parentheses. Now notice it says array 1 and array 2. So we need to select our X, all of our X's, comma, and then select all of our Y's, and then close the parentheses, and it cranks out a value. Now notice that this R value is 0.937863. That tells us that we have a strong correlation between square footage and sale price in thousands of dollars. Now, I know that the correlation does not imply causation rule doesn't necessarily apply here, because if you've ever purchased property in your life, you know the bigger the property, the more money it is. But that also depends on other factors. So you can say that they're related, but the price of a property does have other factors other than the square footage of the property. So again, correlation does not imply causation. So that's how you do it. I'll do it one more time. Equals, C-O-R-R-E-L, parentheses, select your data, comma, select your data, parenthesis. Okay? So now, oh, who said you could delete that? So now let's go back to our slideshow and talk about the line of best fit. When you are describing a relation in the data, we can do that mathematically by estimating the equation of the line. All lines are an equation. If you've had algebra recently, if you've had algebra recently, you may remember this as a linear equation, okay? Where equation, I can spell, I promise, where this is your slope and this is your y-intercept. If you don't know that, I suggest looking at the review videos. Our slope is calculated by the sum of all the x's minus the x bars times y minus y bars over the squares, the sum of the squares, x minus x bar squared. Again, obnoxious formula. Excel does it for us. It takes like 2 seconds to do. And then we plug in the y-mean minus the slope times the x-mean, and that'll give us our y-intercept. But again, Excel does this for us. So let's switch over to Excel if you'll ever let me out of my PowerPoint. My computer doesn't like me. So all we have to do to figure out what our trend line is we're going to click on our dots and right click. If you have an Apple, I believe it's control click. If you are using OpenOffice, it's different. I suggest YouTube. So I'm going to click on add trend line, and it'll draw in the line of best fit for us, so we don't have to do that. And now we can just display the equation on the chart, and it's right there. So I'm going to close that, and that tells me that the equation that best represents our data, so we can estimate further data, has a slope of 2.39 and a y-intercept of negative 60.62. Okay, obviously that doesn't make a lot of sense, because if there's no square footage, you aren't going to be given $60. So we have to actually think about this within reason. And back to our PowerPoint. All right, so I'm going to do an example on page 194 with teen birth rates. You can get this data right from your student CD by going into, actually I can probably get it up for you if I can find it. It's right here. So when you plug in your Discovering Statistics CD, you're going to click on Data Sets. This may look different on your screen. I'm going to click on Excel, Chapter 4, and I'm using teen birth. I already have that open in another Excel sheet. And there are several things that I want you to do to it so you can follow along and practice with me. And you're going to have to do this for your homework as well. So back to the PowerPoint for the directions. So it says that I want to construct the scatter plot, estimate if there's a correlation, then calculate the regression coefficient, and then calculate the line of best fit. So we're going to go do that now. Excel to the rescue. So I have data categorized by state, overall birth weight, and the teen birth rate in that state. So we're comparing birth weight versus birth rate. So insert, scatter, and then we need to do our title. So birth weight versus teen birth rate. Axis labels. Horizontal is the overall birth weight. And then our vertical axis is our teenage birth rate. Oh, that didn't work. That's not working. Why are you not working? teenage birth rate. And now we can delete our legend. And we need to calculate the trend line. So I'm going to click directly on the data, right click, and I'm going to go add trend line, display equation on chart, and then I need to calculate my R, equals COREL, select my X's, select my Y's, close the parentheses. I have an R that equals 0.82. So we can say, because it's between 0.7 and 1, that there is a positive relationship between the overall birth weight and the teenage birth rate in certain states. Okay? So as the overall, now not saying that birth weight makes teenage birth rate go up, or that teenage birth rate is high, you're going to have an overall large birth weight. But they're saying that there is a relation. Okay? It's not causing one another, but these two columns of numbers are related. Okay, hopefully that makes some sense, and I would like to close with something a little funny for us. This is from a comic from a website called xkcd.com. Not all the comics are safe for, and they're not politically correct either, but this one is really cute. And it thinks that, you know, it's a couple arguing and they're showing a negative decline in the relationship on the graph, but the gentleman, he thinks that he can do better than a girl who doesn't label her axes. And when you're doing this, you need to make sure that you have your labels. Graphs that don't have labels don't tell us what we're comparing. So we need to make sure that we know what we're trying to communicate. So God only knows what she's based this chart on. So when you're doing your work for me this lesson, make sure that you label your axes correctly. And happy graphing.